Time is not what we think. It's a mysterious and complex phenomenon that has puzzled scientists and philosophers for centuries. It's not a steady drumbeat the same everywhere. Instead, time can vary depending on where you are and how fast you're moving. Imagine time as a river flowing through the universe. Just like a river can have different currents and speeds, time can flow differently in various parts of the cosmos. Sometimes the river speeds up, sometimes it slows down. This variability in the flow of time is a fundamental aspect of our universe. This is called time dilation. It's a phenomenon predicted by Einstein's theory of relativity, where time stretches or contracts depending on your speed and gravitational field. The faster you move, the slower time flows for you. This means that astronauts traveling at high speeds experience time differently than people on Earth. This is not science fiction. It's a real effect that has been measured and confirmed by experiments and observations. Einstein's theories of relativity tell us that time is relative. It can change based on your speed and the strength of gravitational fields around you. It changes depending on how fast you're moving compared to something else. This means that time is not a universal constant, but a flexible and dynamic part of our reality. Einstein's theory is like a magic trick, but it's real. Imagine a world where the very fabric of reality bends and twists. That's what Einstein's theory of general relativity is all about. It's not just a set of equations, it's a new way of understanding the universe. It says that space and time are connected. Think of them as two sides of the same coin. When you move through space, you're also moving through time. They form a fabric called space-time. This fabric isn't just a backdrop, it's dynamic and can be stretched and compressed. Massive objects like planets warp this fabric just like a bowling ball on a trampoline. The heavier the object, the more it warps the space-time around it. This warping is what we feel as gravity. It's why apples fall from trees and why planets orbit stars. But it also affects time. Time doesn't tick at the same rate everywhere. The closer you are to a massive object, the slower time runs for you. This phenomenon is known as time dilation, and it's been proven by experiments and observations. Imagine two clocks, one on Earth and one on a spaceship zooming near the speed of light. The clock on the spaceship will tick slower than the one on Earth. This isn't because the clocks are broken. It's because time itself is flowing differently for each clock. If the spaceship could travel at the speed of light, time would stop completely. Time dilation isn't just a cool idea, it's real and important. This concept, predicted by Einstein's theory of relativity, means that time can pass at different rates depending on how fast you're moving or how close you are to a massive object. It's a mind-bending idea that has real-world applications. GPS satellites in orbit experience time slightly differently than us on Earth. These satellites are moving at high speeds and are farther from the Earth's gravitational pull, causing their clocks to tick a bit faster than those on the ground. Without correction, this tiny difference would lead to significant errors in navigation. Engineers have to adjust for this difference to make sure our GPS systems are accurate. They use complex algorithms to synchronize the satellite clocks with those on Earth, ensuring that the GPS signals provide precise location data. This adjustment is crucial for everything from navigating your car to coordinating emergency services. So the next time you use your phone to find your way, remember, you're using Einstein's theories to navigate. It's amazing to think that a theory developed over a century ago is now an integral part of our daily lives, helping us find the quickest route to our destination. Time dilation shows us that the universe is a stranger, more wonderful place than we could have imagined. It reminds us that our everyday experiences are just a small part of a much larger, more complex reality. The next time you look up at the stars, think about the incredible science that makes our modern technology possible.
Got a question about how something really works? Drop it in the comments and we might cover your topic in our next video.